Hey everybody, in this video we're going to keep talking about polynomial division. In the last video we talked about long division. I said there were two types that we're going to do. The second one is called synthetic division, and that's what this video is going to talk about. So like I said, in the last video we talked about doing long division problems that looked kind of like this. They were kind of big, they were kind of ugly, and maybe you don't like that very much. And maybe you want to say, is there a better way? Is there an easier way? Is there a less convoluted and kind of prolonged way of dividing polynomials? And the answer is yes, there absolutely is. It's called synthetic division. So I showed you long division first because it's kind of the more convoluted way. Synthetic division is much more simple. Okay, so here's what synthetic division looks like. If I'm given two polynomials to divide by, and I want to use synthetic division, here's how we're going to start. Similarly, with long division, we're dividing by x plus 1, so I'm going to start with that polynomial. But here's what I'm going to write. Instead of writing all the polynomials out, first I'm just going to look at the 0 that I get from this factor. I'm going to flip this sign. We've talked about that a lot. That's how you get the 0 based off that factor, or the x-intercept. So I'm going to flip that sign, and it's going to give me a -1. So I'm going to write -1. Okay. And then what I'm going to do is I'm going to take all of the coefficients from my dividend. Okay, so that's the bigger polynomial that we're dividing into. And I'm just going to write all the coefficients. So it's 3, -4, 2, and -1. I notice I didn't write any of the x's or anything like that. I just took the coefficients. And also notice that I'm not missing any terms. I've got third, squared, first, and constant, so I'm not missing anything. Once I have all those numbers, I'm going to write in this little organizational piece, kind of an upside down division sign to separate this piece over here, the 1, from everything else. All right, so that's just going to keep me organized. So then I'm going to go through this process of synthetic division. What I'm going to do, I'm going to take the first number and I'm going to drop it down here. So it's going to write the 3 down there. Okay, and then I'm going to do this process of multiplying and then adding, and then multiplying and then adding, and multiplying and then adding. Let me show you what it looks like. I'm going to do -1 times 3. That gets me -3. I'm going to write that up here. And then I'm going to add these two numbers. -4 plus -3 is -7. So I did multiply and then add. And then I'm going to do the same thing. -1 times -7 is 7, and 2 plus 7 is 9. Let's do it again. -1 times 9 is -9, and -1 plus -9 is -10. Okay, so there is nothing else for me to do. I just did multiply, add until there were no more numbers. So this final number over here, -10, that number is my remainder. Okay, that's the final number that I see. That's my remainder. So here's how we're going to write our answer. Similarly to with long division, we're going to write it a little bit. It might seem kind of strange. I got to take the quotient, which I get from these numbers down here. All right. Something we need to talk about before we write that out, though. The original polynomial that I was dividing was a 3rd degree polynomial. Okay. So after I divide something out of it, it knocks it down a degree. So whatever my degree was when I started, my quotient is just going to be 1 degree less than that. So it's going to have to be a 2nd degree. These numbers give me the coefficients of that polynomial. So it'll be 3x squared minus 7x plus 9. And again, I started with a square because my initial dividend was a 3rd degree. I had to knock it down 1. Okay, and then I got to put my remainder in there too. So it'll be the same as the last video, plus the remainder over the divisor, x plus 1. And this is going to be my final answer. Okay. So it's definitely not as convoluted as long division, right? I know it might seem kind of like a weird process on the front end, but once we practice it, it'll become we'll get pretty good at this. It's a lot more efficient than long division. Let's do another example, okay? So we're going to do synthetic division again. So again, I look at my divisor, x plus 1, and I flip this sign. So it's -1. I can write in my little organizational piece there. And now I'll write out my coefficients. So I have 1x cubed, 4x squared. And then notice how I'm missing a single x term, right? There's no x. I've got x cubed, I've got x squared, but there's no single x. So I need to write in a 0 to represent the single x space. Okay, so I have 1x cubed, 4x squared, 0x, and then -6. Okay, now let's get into the multiply, add. So subtract the 1. -1 times 1 is -1. So multiply, and then add. 4 plus -1 is 3. Multiply, add, multiply, add. So that gives me -3. Okay. So again, -3 is my remainder, because that's the final number that I see. If this number is a 0, that just means that there is no remainder, but right now we do have a remainder. So my final answer will look like this. My dividend initially was a degree 3, right? So we got to drop it down 1. So it's going to be 1x squared plus 3x minus 3 plus the remainder over divisor, x plus 1. And then we're done. Okay? I want to show you that example to show you that when you're missing a term, you have to make sure you add in that 0 to represent that missing term. Otherwise, things are not going to work out very well. Okay? Let me show you 2 more things, and that'll wrap it up for this video. You might see a problem that looks like this. It says determine whether x minus 3 is a factor of the given polynomial. Let's think about what factors mean for a minute. Factors are numbers that divide another number evenly. Okay, so for instance, like 4 is a factor of 8 because 8 divided by 4 is 2. It divides evenly. It doesn't result in a remainder. Okay, it divides without a remainder. So in order to determine if this is a factor of this polynomial, we just need to ask ourselves, does it have a remainder? If we divide these things, will it end up with a remainder? If it does, it's not a factor. If it does not have a remainder, then it is a factor. Okay? So here we go. Let's divide them and let's see what happens. We'll use synthetic division. So again, I got to look at this thing. I got to flip the sign. So that's 3. Put in our organizational piece there. Get all my coefficients. It's 1x cubed, -1x squared, -14x, and 24. So we can get started. Drop the first number. Multiply. Add. Multiply. Add. -14 plus 6 is -8. Multiply. 3 times -8 is -24. Add. 24 plus -24 is 0, right? So I get no remainder. There is no remainder when I try to divide these things. Okay? So remember, we ask ourselves, does it have a remainder? And if the answer is yes, if there is a remainder, then this thing is not a factor because it doesn't divide evenly. But since there is no remainder, this thing is a factor. It is a factor of the polynomial because it divides without a remainder. Okay? So again, the trick there, if it asks you to determine whether or not it's a factor, you just have to divide it. And if you do not get a remainder, then it is a factor because that means it divides evenly. Okay? And one more thing to talk to you about in this video, something called the remainder theorem. The remainder theorem. The remainder theorem is a little weird upon first glance. This is what it says in math lingo. If f of x is divided by x minus k, then the remainder is equal to the value of f of k. So what that says is that if you divide a polynomial by some factor, the remainder is equal to the value that you would get if you plugged the 0 associated with that factor into the function. Okay, so that still might not make a ton of sense. Here's a little example for you. If you divided some polynomial by x plus 4, and you got 102 for the remainder, you could say that 102 is what you would get if you plugged -4 into the function. Remember, -4 is the factor that's associated with that 0 if you flip that sign. Okay. Let me give you an example of this. I'll show you one example of it. It says, use synthetic division to find out what the value of f of 4 is. Okay. Well, it did not give me a factor, right? It just gave me a number. It wants me to find the value of 4. Okay. So what we're going to do, we're simply going to divide by that number. We're just going to divide by 4 because that's the number that it told me to divide by. I don't need to flip any signs. I'm just going to divide straight up by 4 because that's the number that it gave me. So I'm going to set up synthetic division with 4. Okay. Let me make this a little bit bigger. Okay. My coefficients are 1x cubed. Notice how I'm missing an x squared, so I got to add in a 0 for x squared. I have -13 and 12. So let's go ahead and get started with multiplying and adding. Drop 1, multiply, add, multiply, add, multiply, add. Okay. So here's what happens. I end up with 24 as my remainder. So what the remainder theorem tells me is I can say f of 4 is 24. Whatever, if I plugged 4 in for x in this equation, I would end up with 24. Okay, because that's what the remainder is when I divided it. I know that might be a little bit confusing upon first glance. I don't expect you to be a pro just from watching this video. So we will practice that and talk about that a little bit more in class. Okay, so that is it for synthetic division. If you have any questions, feel free to email me, and we will see you guys next time.